Okay, here we're applying this to a real world situation. The real world being we've got a tower at an elevation of 11 degrees, and they've labelled that for us. We're walking 80 metres towards the tower, which creates the side of the triangle, and then we've got a new angle of elevation there at 36 degrees. We need to show, this is interesting, we need to show that A equals 80 sine 11 over sine 25. So that's the same sort of question, just framed in a different way. We're basically trying to find out A based on the information we know. They've labelled the points of the triangle for us, so that's easy. And we've got here though, A, B, D. A, B, D. So the formula we're going to work with, hopefully this works, is A over sine A equals B over sine B equals D over sine D. Which bits do we have enough information to actually tick off? So starting with A, we're interested in A, and we can find out sine A. So that bit, we've definitely got that bit down. B, we don't know. We can work out angle B if we need it though. D, we know. And we can actually work out angle D if we need it. So let's go with this bit. To work out angle D though, the angle at point D, we first of all need to know this angle. So we've got a straight line here. We know that the angle of a straight line is 180. So this angle here is going to be 180 minus 36, which is 144. Now that we've got two angles inside the triangle and we know that they add to 180, thank you, comes out at 33 degrees. Now we have all the information in our triangle, we can apply the sine rule. So if we go A, which is what we're trying to find out, so A over sine A, which is 33, is going to be equal to B, sorry, no, not B, D, 80 over sine, sorry, A over sine A. Sine A is actually sine 11. It's 80 over sine 33. We now need to solve for A. What are we going to do? We're going to multiply both sides by sine 11. So sine 11 times sine 11. The sine 11s cancel on this side, and we equal A equals 80 sine 11 over sine 33, which is not what we were expecting. We wanted 25, so something's gone wrong. 144, 155. What's that angle really? 25? Okay, so that angle's 25, 25, 25. Okay, let's look at B. Now that we've shown that, all right, including correcting our error, evaluate the height, which is this height in metres of the tower corrected to decimal places. So we're actually now dealing with a new triangle. Even though same example, we're dealing with a new triangle where we know certain things. We now know what A equals, even though we haven't evaluated it. So tick. That's actually a right-angled triangle, isn't it? Because it's a height, so we could probably use trig. We're trying to find out the opposite, and we know the hypotenuse, so we're in trig ratio territory. So let's, if I can clear some of this off, we're going to say sine of 36 is equal to the opposite, which is h, over the hypotenuse, which is this. So this is going to be tricky because I've got a double. I'll just do it h divided by 80 sine 11 over sine 25. We need to solve for h, which means multiplying both sides by this value. So let's do that. If we multiply by 80 sine 11 over sine 25, they will cancel, and you get 80 sine 11 over sine 25 times sine 36. I'll just make that simpler, and we'll get h is equal to 80 sine 11 times sine 36 all over sine 25. Okay, let's see how we go. Magic calculator, what did you get? You got 21. So I'm going to go 80 times sine 11 times sine 36 all divided by sine 25. What did you get? I got 21.23. What does the magic answer say? Did I get it right? 25. So h equals 21.23. Well, we've lost the question. Okay, to 2 decimal places, heights in metres.